Hey guys, Dr. Brown here with Kubo Math, and tonight we're looking at parabolas. So this will be for the pre-calculus class or anybody that wants to check out parabolas. Okay, we'll look at first at the nomenclature of parabolas and then work a few simple problems, and then, you know me, a few word problems then after that. All right, stick with us here. All right, let's say we have a parabola. Now, you already know I have no artistic ability. This point's called the vertex. Okay, in this case, we're going to put it at the origin of the graph. We've got a x and y. But this line is the axis of symmetry. This is the vertex. In this case, it's at 0, 0. Let's see. Now, there's a point here called the focus. I always refer to that in my mind as the focal point. And you'll see why in just a moment. But there, it's from the vertex, it's at a distance called P. Now, there's a line below that. It's the same distance below that. It's also, the distance would be P. Okay. Now, of course, this is the point 0 minus P. And this is the point 0, P. Now, and there's that directrix, that's hard for me to say. Okay, so it's down here at a point, as we mentioned, y equals minus P. So it runs that P distance below the vertex, then the focus is P distance above the vertex. Now, the cool thing about parabolas, at least what I think is so cool, is if you go from the focus out here to some point, we'll call it x, y, and you go down, straight down to the directrix. Now, my graph doesn't show this properly, but this distance will always be the same as that distance, always. The other thing that's really cool about them is, let's say you have a flashlight bulb here at this focus shining, and that light comes off and hits it right here. It will bounce out parallel to the axis of symmetry, no matter where it hits. Anywhere it hits, it bounces straight out. That's how your flashlight works, where you get a little small little bulb in there, or LED, light emitting diode, and its light bounces off that parabola that's inside and shoots that beam way out. I also would invite you to look on the web at solar cooking, where people will take your cable dish that's outside, maybe it's in a parabolic shape, and then they'll coat that where it's shiny, almost like a mirror image, and then that has a focal point to that also, so they'll put it in the sun, and you don't want to put your hand here, it'll burn you or cut your fingers off. It's concentrates all the sun's rays that come in all to that focus, and people will hang a pot there to cook, so they can have solar cooking. So look that up on the web. It's quite interesting. Okay, and I'm actually in process of trying to make one of those. Okay, all right, so that's a parabola. That's some of the nomenclature of a parabola. All right, so, but what's the equation for that? All right, if I come straight down, at this point here would be x minus p, because I'm at the line y equals minus p. This point was 0p, and I'm coming out here to some point xy. Well, let's use our distance formula to find the distance. Now again, this is not drawn to scale. If it were, that line would be the exact length of this one. But let's find the distance, do the distance formula of each, and then set them equal and see what equation pops out. So we would have x minus 0 squared plus y minus p squared, the square root of that, and that's equal to x minus x squared plus y minus a minus p, so that would be y plus p squared, and the square root of that. Well, for the sake of space, I'm just going to square both of those, and that'll take that radical sign off of both. And I end up with that. So now x minus 0 squared, I'm going to scoot over just a little bit, is x squared. And then squaring this one, I end up with y squared minus 2py plus p squared. And that equals x minus x squared, 0 squared is 0. I'll go ahead and put it there so you'll know I didn't forget it. Okay, and now y plus p squared would be plus y squared plus 2py plus p squared. Okay, if I subtract p squared from both sides, that cancels. If I subtract y squared from both sides, that cancels. So I end up with x squared minus 2py equals 2py. Well, let me add 2py to both sides. So these minus 2py plus 2py cancels, and I end up with x squared equals 4py. And that is the equation for that parabola. Now some things to note here. If p is positive, then this parabola turns up, and that just makes sense because p is on the y-axis here and it's a positive number. So p greater than 0, the parabola turns up like that on this equation. If p is less than 0, obviously if p is a negative number, it turns down, the focus would be here, the directrix would be back there. Okay? Now there's another equation. If the parabolas turn left or right, it's y squared equal 4px. Okay, in that case, it's saying that if p is greater than 0, then the parabola is open in this case, because now p is along the x-axis and the focus would be over there. It's positive. But if p is negative, then its focus is over here and it's turned to the left. Okay, so those are the two equations that we're going to work with, and work just a few problems to try to understand how we can use this. Okay, I'm going to pause the video and then clean up the board and be right back. Okay, I'm back. All right, I've written our two equations up here, and there's three things as we work through these problems we want to know: the focus, the directrix, and the focal diameter. Now I didn't mention the focal diameter, but what it amounts to is, let's say this is your parabola and it's at the origin, that's the vertex, here's the focus. It gives you that diameter on a line that cuts directly through the focus that's parallel to the directrix. Okay, so and that diameter is 4p. So really it becomes this part of the equation. Okay, all right, so that said, let's take a look at What if we had x squared equals 2y? What could we say about that? Well, we know we have this situation, so it's either open up or open down. Okay, so the form of the equation is x squared equals 4py. Well, you can see that it appears to be that 4p equals 2. So 4p equals 2. Divide both sides by 4. 4 over 4 cancel. P equals 2 over 4 equals 1/2. So now I know I have P equals 1/2. So let's say this is 1, 2, -1, -2. We know that P is 1/2. So it's sitting here. There's 1, there's 2. -1, -2. So now my directrix is here at y equals minus 1/2. So P equals 1/2. Y equals -1/2. It's the directrix. And then the equation so this is 4p. So my focal diameter is 2. So it's saying that this distance all the way from here to here, that width would be 2. So I've got 1 on each side, right? Okay. And that would be how you take that equation, these equations, and come up with a little bit of some more information about that parabola. Okay, let's look at another one here. What if we had x squared equals 16y? Remember, our equation is x squared equals 4py. So 4p then must equal 16. Divide both sides by 4. Okay, so p equals 4. So now you have a situation where you have this 1, 2, 3, 4. So my focus is up here, there. We'll label it here. So p equals 4. 1, 2, 3, 4. My directrix is out here at y equals -4. Okay, I'm still at the origin. What else? The focal diameter was 16. So it's telling me that this distance right here is 4p or 16. Obviously that one's really not drawn to scale. All right. What if we had we're given the directrix? Okay, so we have a situation where we have a grid here, and we know that the directrix is at x equals 2. So now I have a directrix at x equals 2. Well, if that's 2, then my focus is going to be over here, 1, 2. So I know that my parabola looks like that. So I'm at the point of x equals -2, 0. So p equals -2. So we have y squared equals 4px. But p is -2. 4 times -2 x. So this equals -8x. So what's my focal diameter? It's it's 8. That's absolute value of that number. So it's 8 units across here. Focus at p equals -2. Focus is at the point -2, 0. X equals 2 for the directrix, and then the focal diameter is 8. Okay, what if we have a full-blown equation here? What do we do about that? What if we have 5x plus 3y squared equals 0? Well, just solve it for, since we have a y squared, let me subtract subtract 5x from both sides. So that's a negative 5. 0 minus 5x is negative 5x. Those cancel. So I have 3y squared equals minus 5x. Divide those by 3. So y squared equals minus 5/3 x. So recall our equation. Y squared equals 4px. So it must be that 4p equals negative 5/3. 4p equals negative 5/3. Divide both sides by 4. And that equals negative 5/12. So p equals negative 5/12. It's kind of an odd number, isn't it? I've stretched my 1 way out there. All right, so my equation then would be y squared equals 4 times negative 5/12 times x. So p, negative 5/12. If that's 1, 6/12 would be 1/2. So we're just a little bit less than 1/2 here. So since p is negative on this y square, I know it's like that. I've had all of those slid down. Just imagine that's symmetric, okay? Actually, let me try to fix that a little bit. That's a little better. Okay, then my diameter, my focal diameter is going to be 4p. So it's just 4 times this number, which is minus 20/12, or actually it's the absolute value of that. That's the focal diameter, equals the absolute value of 4p. So that goes back to that negative 5/3. So this guy's, it's absolute value of negative 5/3. So this whole distance right there would be 5/3. What else we have here? The focal point is minus 5/12, 0. So that's F right there at that point. Then the directrix obviously is at coming down through like that, which would be x equals 5/12. And that's how you would handle that. Just solve it for y squared. Okay? Now then, oh, we're ready for the stuff. Now, we have 2 word problems here. And let's see what we can do with them. I don't know if everybody else in the world likes word problems, but I certainly do because they're realistic. We've got to get where we can solve these. Okay, number 1, a lamp is put into a parabolic reflector and the focus, or at the focus. So they've put this, they've got a parabolic shape. Hopefully their flashlight looks better than that one. I'll tell you what, we'll try to put it like that. We've got our flashlight turned up. We got our vertex here. We've got our axis of symmetry here. We've got some focal diameter. It gives us the focal diameter. And it says that focal diameter is 12. centimeters. Now we know, in this case, we've got, this thing is open up. That's my x-axis, that's the y-axis. We've got a directrix out here somewhere. This is going to be our focus. And we've got to figure out what P is. Well, 4P, the absolute value of 4P equals 12 centimeters. Okay, so 12 over 4 equals P. Okay, so 12 divided by 4 is 3. So I know that P is 3. So that means I'm setting up here at the point 0, x is 0, y is 3. Okay. Of course, they're asking us, the first part of this is what's the parabolic equation? That's what we're working on here. If P is 3, I know my directrix is down here at y equals minus 3. So I'm below the x-axis. Okay, so y equals negative 3. So this point would be x is 0, y is negative 3. Okay, what else do we know here? Focal diameters. Oh, so we've got everything we need, don't we? So y or x squared. This is since the shape for x. X squared equal 4py. So x squared equals 4 times p was 3y. So x squared equals 12y. Now we probably could have just picked that up immediately because our focal diameter is 4p. We would have known, well, 4p is 12, so this is 12 because that's 4p. But I wanted us to work through this to just see if we could arrive at the same equation. So x squared equals 12y. Oh, now what? The parabola diameter 20 centimeters beyond the focus. What they're wanting us to figure out, all right, if this parabola goes on out and we're 20 centimeters beyond the focus. So from the origin, that means we're 3 plus 20, right? So we're sitting here at the point y, x is 0, y is 23. And they want to know that diameter right there. Excuse me. All right, so we're sitting there. They want to know the parabola diameter at 20 centimeters beyond the focus. So we're 3 plus 20, we're sitting up there at 23. So y equals 23. So we can solve for what the value of x would be, which we would just have one, well, since we're going to do a square root, we'd have plus or minus. So let's work that over here if I have enough cable. So we've got x squared equals 12y. X squared equals 12, which is in our equation here, 12 times 23. So 23, 12, 2 times 3 is 6, 2 times 2 is 4, 1 times 3 is 3, 1 times 2 is 2, 6, 7, 276. All right, so we need x squared equals 276. So x equals the square root of 276. Hey, do you want to go old school here? Why not? Let's do the square root of 276. Now we know that the 15 squared is 225. 16 squared is 256. I don't know what square root of 276 is, but I do know this, that if I want to find the square root of 276, well, that equals the square root of 256, which is 16. I know that. Plus 1 over 2 square root of 256 times delta x, the difference between this number and that one. Well, that one's 20 larger than this one, so it'll be times delta x. Okay, square root of 256 is 16 plus 20 over 2 times, and this is 2 times 16. So I've got 16 plus 20 over 32. Well, 16 plus 20 is 4 times 5 over 4 times 8. The 4's cancel, so I've got 16 plus 5 over 8. Well, 16, I'm going to get a common denominator of 8. Okay, so 16 times 8. 8 times 6 is 48. 4, 128. So 128 plus 5 equals 133 over 8. You're probably thinking, what does that mean? Well, that means that distance right there is 133 over 8. Well, what is 133 over 8? Okay, I'll play along. 133 over 8. All right, 1 times 8 is 8, 9, 10, I've got 53, so that gives me 6 times 8 is 48. That is 5. Bring a 0 down, so now I've got a decimal here. 6 times 8 is 48. Bring down a 2, another 0. 2 times 8 is 16. That leaves me 4 and 5. 16.625. Now if you put that square root of 276 in your calculator, you'll get a number really close to that. And this is the way they used to do this in times past. They didn't have the calculator, so they had derived a few things they knew, and when they end up with something they didn't know, they could go about it this way. And how that works is you're taking a derivative, which you haven't learned in this class yet, so let's not go there. But if you knew the square root of 225 was 15, I'm sorry, if you knew, say, the square root of 17, whatever that is, you would be subtracting this because the number you knew was higher than this one, the one you want to know, so you would be subtracting. So, all right, a little old school work there. So what is this? 16.6 was that distance, and since we did the square root, it's plus or minus that. So we have minus that number, so this distance, so 16.625, 16.625. So that's what that focal diameter would be. The sum of those two numbers, 32, 33 something. Okay? All right. That's how we can do number 1. Let's think about number 2 here. I may just clean out a small spot here. All right, a person is standing on a bridge. And if you can see this graphic over here, they're standing here, and we considered that the origin of the graph, 0, 0 points where they're standing. And they throw a rock, throw a stone or a rock off. Where I grew up, they were rocks, okay? But they threw that horizontally. Obviously, gravity grabs that and pulls it down, and its arc path ends up being a parabolic shape. But the rock lands 40, these are all meters, so it lands 40 meters away from, if they drop the rock straight down, the rock actually lands 40 meters from where it would have been directly below them. So the distance from where they're standing down to the water level is 25 meters, and the rock lands 40 meters beyond that. So the question is, what's the equation of the parabolic shape? Now, if you think about, they're standing up here. They're standing right there. And they throw the rock off, and it goes down. So really the parabola is open down, right? And since this is 25 meters down, it's a negative 25. And this is, since this, you know, that's where their x-axis, well, actually the x-axis is there. But that distance it travels out was 40 meters. Distance down, 25 meters. So since it's in this shape, it's still an x squared equals 4py. So if we're trying to find the equation, we could say we don't know p, but we have an x term and we have a y term. X squared divided by 4y equals p. How about we do that? So now we have 40 squared, 40 meters squared, divided by 4 times y, a negative 25 meters. So I end up with 1600 meters squared divided by a negative 100 meters. Meters squared divided by meters gives me meters, which is good. 1600 divided by a negative 100 gives me a negative 16. So now, going back to this equation, I have x squared equals 4 times p, which is negative 16, y. All right, so we can go to, I guess I should erase this and draw it better. So now we have a situation where we have this right here. He's coming down like that. We know that distance was 40 meters minus 25. And we know our equation now is this. We know P is negative 16, so it's somewhere in here. That's negative 16. Okay. My directrix, I know, would be up here somewhere, and it would be at 16 above. So I would have that point 0, 16. And this focus here would be at 0, negative 16. So if I take 4 times negative 16, what does that give me? A negative 64. So now I have x squared equal negative 64y. And that would be the equation of that. Now you're probably thinking, well, is it really? Okay. Let's see how we can challenge ourselves. If you took, what's the value of y? So x squared divided by negative 64, and that would give me the value of y. So if I went out here, well, 40 squared divided by this negative 64 would give me, should give me a negative 25. So let's say 40 squared, that goes back to that 1600, you know, and it should come out to a negative 64. 1600 divided by negative 64 would give me that negative 25. Let me grab my calculator and confirm that. Yes, we're looking good. It's just a little messy though. So we could confirm then that 40 squared, we had x squared divided by the value of 4p, which was negative 64, and that gave me my negative 25. So if I went all the way out here to 40, what was my distance down? That was negative 25. So that x squared equals 4 times negative 16y, which was negative 64y. That's the equation of that parabola. Okay. Sorry for the messy content and maybe going old school. Maybe that was too much. I don't know. All right, this is just a brief overview of parabolas. And as time goes on, we're going to look at ellipses and various other items in conic sections. And we'll slowly walk through those, and then we'll see where all this pre-calculus takes us. Why are we doing this? Okay, we're doing it because we're trying to build a better tomorrow and do that through math. So study, study. I can't overemphasize that. Just like the basketball player, if you want to, they don't just hit one free throw and say, yep, okay, I'm good, which is what so many of us do in math. We get one right, whew, okay, that's enough of that, and we move on. We don't need to do that. We need to continuously practice, just like the professional basketball player, because one day you'll be out into the job market as a professional. So just like the basketball player, a professional, they keep practicing, not till they get it right, but until they can't get it wrong. And that's what we want to do as professionals in the job market. Okay, that's all for now. We'll talk to you next time. Thanks.